Good morning everyone. In this video we're doing something very different based on what the theme of the channel is. We're looking at something accessory here in terms of a bonus video. Something you may want to know or you may not want to know, but something rather more to inspire you than anything else. We're looking here at the relationship between a circle and the tangent line. I won't be presenting any material which is higher than the high school level. If there's anything in terms of a concept that needs to come in, which would be slightly difficult, I'll present that out as a given and you won't have to worry about how it was determined. The relationship between a circle and a tangent line is this. Many of you will probably know this from geometry. If you have a circle, there's a center, you draw a radius. If you draw a tangent line and that tangent line will touch this radius at the point P, whatever this point P is, you know that the tangent line and the radius must always be perpendicular. What's a tangent line? A tangent line is a line which grazes a curve at only one point. It barely touches it, right? It skims on it. If this right here is a point, if you want to draw a tangent line, it'll go like this. That right there is a tangent line which grazes a specific point on a curve, alright? You don't want to be drawing tangent lines on straight lines because you can't ideally do it. Your tangent line would basically be exactly that line because all the points would be touching. But on a specific curve, only a single point touches that tangent line, and then right there is where you have that grazing occur. Anyhow, for any circle you have, if you draw a radius, right, or you can say this, if for any circle you have, if you draw a tangent line and then you connect that tangent line to that center, right, that by a radius, that radius and the tangent line are always 90 degrees. It's a geometric theorem which has been proven. What we will do over here is to prove it for you in a very good manner, something that you might actually appreciate or something you might actually learn. And how will we go about proving the fact that a tangent line and a radius touching at a specific point on that circle are always perpendicular? We need to be able to look at how we can do slopes of a curved line, but we're not going to learn that procedure because that procedure is calculus. I'll provide you that material. If supposedly you have a specific point over here, you know there's a specific factor which comes into this play. If you put a factor, it's like a slope factor, right? If you were provided this, you would put your x or your y value over here or both, and it would give you very well the slope that you need. That factor I will provide you. Think about a circle like here. If you have a specific point over here and you want to determine the slope of that point or any line on that point, you need that factor. It's called a derivative factor. I don't want to use specific terminology. I will provide you that factor. That factor for the purposes of this video will be minus x over y. How it's determined is calculus. We don't need to worry about how it's determined. It is very well determined by using the slope formula y2 minus y1 divided by x2 minus x1 as a formula specific and similar to that slope formula for a straight line, except it's modified a little bit by use of some calculus techniques. But understand that this right here is your slope formula you need to save and utilize for this specific video. So let's get to this point. So now our task is this. If you're given this at any point on a circle, if you were to draw a tangent line, its slope can always be measured by that. All you have to do is put the x and the y value at that specific point, and whatever you compute is your slope. Alright, we have to show why the tangent line and the radius are always perpendicular. Two lines are perpendicular and you know what their relationship are with regards to a slope. If one has a slope of m1, the other one must be a negative reciprocal of that, and you know that. That's a very simple geometry rule or coordinate geometry. If two lines are perpendicular to each other, one line has a certain slope, the other one is a negative reciprocal slope. Or you can say it's m1 times m2, right, is equal to minus 1. If you were to multiply the slopes of two perpendicular lines, their slopes would equal a minus 1. So this right here is another rule you must remember. You must know this and you must know this, and let's get to it. How do we do it? Well, what we do is we draw a x and y plane and we draw a unit circle. You identify a point over here, let this point be P, and it's made up of a certain x and a certain y coordinate. If this right here is a center, you connect a line from the center to that point. What you can do is create a right triangle, and that's exactly what we need to do, a right triangle. This right triangle has a certain base which is x, a certain height which is y, and a certain hypotenuse which is r, which is the radius. Any of these lines going from the center to any of these points on the circle are all radius. How can you determine this point right here? Well, you have a certain angle here, theta, and just think about basic trigonometry. Cosine theta is equal to x adjacent over hypotenuse, right? Sine theta with regards to this angle is equal to opposite over hypotenuse, y over r. In each instance, solve for x and y. x here is equal to, you take r on the other side, r cosine theta, and here y is equal to r sine theta. And remember, I identified this point p x comma y. Well, now it's become, your point is really r cosine theta, and it's become r sine theta, right? That's my point right here. At any point on your circle, you can demonstrate it in terms of these coordinates. Now what we have to do is determine two lines, a segment and a line. Actually, one of these segments is this radius, and the other line will be this line, which is tangent. I'm telling you this is tangent to that point, and the radius is touching it, and we know by the rule that it must be 90 degrees. We have to show you why it's 90 degrees. So these both lines must be perpendicular to each other, hence they have that 90-degree relationship. If you look at this point here, the segment, the radius, and this, we have two coordinates. You have 0, 0, which is the center of the circle, the origin, and then we have this r cosine theta and r sine theta. If we find the slope of this radius segment, what is it? x1, y1, x2, y2. The slope is y2 minus y1 divided by x2 minus x1, right? The slope of the radius, right? The slope of the radius is r sine theta divided by r cosine theta, and you cancel out the radius because they cancel out. You have sine theta divided by cosine theta, which is what? It's tangent theta. So the slope of this radius, right, has been determined to be tan theta, and we'll save this value right over here. So we've determined one slope, we need to determine this other slope, and they must fulfill this relationship. And how can we determine the other slope? And that other slope refers to the slope of the tangent line. You utilize this factor. We know that the slope of the tangent line, and I've given you that, you're given that. You don't need to derive it, you've been given that. You don't need to understand why or how it came from, you just have to utilize it. Is equal to your minus x value divided by your y value. What's your minus x value? Here's my x, here's my y. You have a minus r cosine theta divided by a y value r sine theta. The r's cancel out, but you have a minus cosine theta divided by sine theta, which is a minus cotan theta. Now think about it, tangent and cotangent are reciprocals of one another, aren't they, right? So we now know that the slope of the tangent, I'm just writing tang, is equal to minus cotan theta. And now we have to actually show why they are perpendicular, and they are perpendicular by means of this rule right here. You do m1 times m2. m1 is this tangent theta, right? And m2 is minus cotan theta, right? The slope of the tangent, the slope of the radius. Multiply them together. You're looking at a tan theta times minus 1 over tan theta, right? Why is it minus 1 over tan theta? Well, you already have a minus. Cotan is the reciprocal of the tangent. You can make it 1 over. It cancels out and you get this minus 1. So you have indeed proven this specific thing you needed to show. m1 times m2 equals minus 1. Therefore, both of these segments and lines, or segment and the line, were indeed perpendicular to each other. The slope of the radius was tangent theta. The slope of the tangent line was minus cotan theta, and they both indeed have a perpendicular relationship because they fulfill this rule. Two perpendicular lines, when multiplied together in terms of their slope, are always equal to minus 1, or you can read it as such over here. All you needed was this derivative factor, or the slope factor, for a circle. At any point on that circle, you can determine the slope of a line tangent to it using that. You don't need to understand it or derive it. All you have to do was use it, in addition to everything else you know here now from trigonometry. And this is very well an understandable proof that you have learned now. So keep this in your mind, and you can probably utilize this at some point in your life. Thank you for watching. Have a nice day.